Okay, so today we're going to take a look at the new triple video multimode filter from LZX Industries. And this is a 3-channel multimode filter. Each channel has a simultaneous low pass, band pass, and high pass outputs. The high pass outputs have some extra options that we'll talk about in a minute via the OLN output. All of these are available simultaneously, which lets you blend them in interesting ways, cross-patch them, do cool stuff, and each one is CV controllable as well. Each channel has a CV attenuverter, frequency control for the cutoff frequency of the filter, and then just like on the oscillators, it's got a frequency range switch, and this goes between different ranges, and we'll talk about in a second how that actually affects the filter. So first off, we can look at it in low-pass mode. It's this first output here. So I just have a still video coming in, and we're looking at the low-pass output right now. This is just patched straight into the color video encoder. I have it set right now up to the highest range, and you can see if I sweep through the frequency, we just get a blurring to the right. And this is effectively what low-pass filters do. They blur things. They push stuff to the right. They work that way because of the way analog voltage works. That should be, if you're not new to video synthesizers, you're used to everything going either down or to the right. In this case, it goes to the right. If we switch down to lower frequency ranges, what you'll notice is that it's sort of limiting the bandwidth of what the filter can pass. So we can't pass higher frequencies because obviously we've moved down to a lower frequency cutoff. So it starts off with a much more dramatic filtering effect and gets increasingly more so as we pull through. Once we get to the lower ranges of this third frequency switch, you'll start to notice that if you ever tried running video through an audio filter before, that's what you're starting to see. And that's basically what's happening right now. We're about in the range of what an audio filter can process. And if we go down, obviously it just gets more and more dramatic. And so basically in these lower frequencies, what we're doing is we're rolling off everything that would be in the vertical range. In other words, any information that would be going vertically, we're rolling off because the filter is down way below the frequency necessary to represent vertical information. And when we get to the very bottom, even more so. Today we're just going to be looking at using this for processing images. And so this top range is going to be the most useful for us, maybe this one too. You can see that this, you know, especially when you get down to the lowest range, you're probably like, what the hell am I ever going to use that for? Probably nothing with video or image-based input sources, but with in pattern synthesis patches, it can be useful for blurring lower frequency oscillators. And you can also use it as a utility to, you know, round off LFOs and envelopes and other types of low rate modulators. So that's basically low pass mode. You get a blurring effect. Switch it to band pass mode, and you get more of an emboss type effect. This is what would be in a computer program like After Effects or Photoshop referred to as embossing. And again, as we get down in the frequency range, you can see what starts to happen. You can do some cool things extracting horizontal data and using that as a modulation source for other things, perhaps. Cool. And then we could switch to high pass mode. And in high pass mode, you get edge extraction. So it's sort of like an emboss effect, sort of like the band pass, but a little bit more extreme. And again, as we get into the lower ranges, you see what starts to happen. Now the high pass, because it's a high pass filter, it's going to continue passing through that high frequency information. So that's why we're still seeing the vertical information, and we're not losing the image because the image is passing through. In fact, when we have it turned all the way up, all the way to the right, all we're seeing are the most detailed parts of the image, more or less, which would be the edges between data, between dark and light areas. If you've done any digital compositing work, you know that edge extraction is a super important part of the process, and it's pretty exciting to have it here in a modular system. Moving one over to the right, we have the OLN output, and I do not know what OLN stands for. Lars can write that in the comments somewhere. But basically what it does is a variation on the high pass output. And it has three options, and that's what this switch is for. The switch that says plus edge, minus edge, and then there's a middle position. On the positive side, all we're going to see are the positive edges. On the bottom side, we're just going to see the negative edges. In this case, nothing. We crank it down until we get to a negative edge. Cool. And then in the middle, it sums the two together. So we see the positive and the negative edges. Any of these filter types can be controlled with a CV input. Here I'm coming from a video waveform generator directly into the CV, and we've chosen a low pass filter type. And you can see as I adjust the CV, right now I'm at LFO speeds, and you see predictably the LFO controlling how much of a low pass effect we get. One nice and interesting effect is if you switch your oscillator up to scrolling range. You start to get some cool dream sequence type effects. This would be pretty much ready to go for that. We can go up even higher, but the effect becomes kind of less exciting. Maybe if you if you added some frequency modulation to this or some sign shaping, it might be a little bit more interesting. And of course we can CV more drastically. So if we switch to the bandpass, see basically the exact same thing, but we can get some interesting emboss effects. And with the high pass. Alright, so this is what I'm calling the melting face patch. It's a little bit more complex use of the filter. It's two low pass filters. One is CVing the other one. So this is the output that we're seeing right now. It's from the top filter, second filter CVing the first. Second filter is being CV'd by just a bunch of LFOs mixed together, and nothing fancy happening there. Okay, and so what's going on here is the video source, in this case the still image, is first coming into channel 2 and getting filtered, and if we look at just the output of that, you can see what's going on there. So what I'm doing is a lower frequency range filtering, and you can see what's happening. Cool. So then when we use that as a CV source on the second filter, we get these distortions of the image, but we're getting more filtering where the image is brighter, and less filtering where the image is darker. So it gives kind of a more complex shape. By comparison, if you look at what happens if we just directly CV the first filter with our modulation source, we get, even if we bring the range down, we get a much less interesting effect. It just sort of skitters the whole image to the right. So it's kind of cool to cross-patch the different channels of the filter. It can give you some really interesting distortions. And it's one of the few ways to get they're subtle, but it's one of the few ways in the system right now to get any kind of geometric transformations, any kind of shifting of position on the image. So that's one cool patch. So here's another quick patch showing multiple filters working together. I have the same image going into the input. I have the high pass output going into the key input on a keyer. And what you're seeing right now is just the key output. So let's see what happens when I adjust the filter settings a little bit. Right, we get more or less of a tear. So I just have this turned all the way up. And again, if you've ever worked in a digital compositing environment, you know this as an edge mat, is what it's referred to, and you use them all the time. And what I actually have patched up here is a very common digital compositing technique that's used for beauty retouching, but the analog version of it. So instead of making somebody look more beautiful, it actually makes them look like a terrifying monster, but same patch. It's kind of fun. So we have our high pass filter, and we have that going into a key input, and this is the key that we're seeing. Then let me switch this over here so that we're actually looking at the output image. And I have patched in here the original video source, which I've multed off of the Y output from my video sync generator, and I'm using that to key over a second low pass filtered version of the same thing. So what I'm doing is using the high pass output to key in between the low pass filter and the original. So I'm going to find just the right key thresholds. You'll see what happens is the high pass filter maintains the sharp details from the original and lets the blurred version sneak through the back. Now of course you could also plug other stuff in here besides the low pass version of it, like oscillators and whatnot, and you know, have that kind of party. I think this patch is going to be really fun once there's a color video input via either the color video interface or the color video decoder, because then you'll see the actual natural colors of his skin and everything sort of smearing, and you'll still be able to maintain the details on the face or whatever your subject might be. So this is another cool, quick example. And one thing you'll notice, it's kind of maybe a little hard to see in this example, but if you look in the detail areas, the colors, the tone from these outlines is coming from the original video. So where the original video is dark, the hairs are dark. So it's not keying based on brightness. We're not finding that outline, or it's not being represented based on its brightness. It's being based on the level of detail in that area. So where you have a lot of detail, which on the human face is around the eyes and the nose and the mouth, you get your key. So it's a cool way to make a detail-based key instead of a value or a brightness-based key. Okay, so here's another simple patch. It's actually not too different from the last one in theory. We pretty much have a key, and we are able to soften the key. And then we are using that softened key to, just kind of like in the last example, to control how these two signals, how the blurred one and the clean one mix together. So we're keying the clean signal over the blurred signal based on what's called a soft key. So let me take you through this and it'll make a little bit more sense. So we start with the Y of the video, in this case a still, and it's going to a keyer first. And if we look at what's coming out of the keyer, we can see our key, just a typical hard key, right? Let's try to key just a bit of his face there. That key is going into the input of one channel on the filter, and from that we're taking the low pass output. And so we see the key, but we're able to soften the key. So instead of getting our usual hard key that you're probably used to from your key generator, you are able to soften it in one dimension. So the output of that goes into the CV control of a second keyer. So here in the input of the second channel, I have the original video back from the source, and again CVing it with the first soft key that we pulled. And as I go to blur the second channel more, you can see that it's blurring everywhere except for the brightest part of his face. And as I adjust the filter threshold on the filter that's softening our key, you can see we get a different range of effects. So you can see what it's doing there, for example, to his right eye, where it's just kind of pulling it across the screen. That's from blurring that key. So, there's some more examples. And again, if we want to look at just the key itself, you can see what's going on in the key. And then the final effect. And of course we can adjust CV amounts. We could further modulate the CV by summing it with a triple video processor or similar, and we could get cool kind of warping modulating effects. Okay, so another fun quick trick is this setting up a triple bandpass filter to do some weird colorization stuff. Right now I have the original video, again plugged it into the filter, a couple CV sources, just oscillators, I'll talk about in a second, and then all three bandpass outputs going to 3 different channels of a video blend matrix. One's plugged just into R, one into the green, and one into the blue. I'm also summing back in a little bit of the original video signal. I'll show you what it looks like with and without that. And as I start to play with the different individual filters, you start to get this sort of RGB separation effect, which is something else you can do very nicely with the filter. I may or may not show that individually. But as you go, you just kind of get these nice color washes that are sort of related to the video. It's not exactly a soft colorizer patch, but it can create these kind of beautiful gradients. And then of course you can add CV and get some sort of different kind of things going on. In this same patch, even though I have bandpasses hooked up right now, same patch will work with high pass outputs. You'll just get a slightly different effect. Switch over to the OLNs. And like I was saying before, I'm summing the original video back in. I'm going through a TVP to sort of attenuate it on its way. And if I didn't do that, it would just be very dark. And so I mix a little bit of the original back in to get the overall level up. If I want to keep this all the way down, and if I want to use the low pass filter outputs instead, I'll get a slightly different but sort of related result. And this is how you could do kind of a true RGB separation type effect if that's something you were going for. I'll bring these CVs down and show you. So yeah. So there you go. And then I can mix in some of the original again and get some of the brightness back. Another fun thing to experiment with the filter, and I hope to show more of this in a different tutorial next time, this one's getting pretty long as it is instead of adding them to the original signal, keeping original signals and subtracting various filters from it. So in this case, I'm just going to subtract a low pass filter. And when you subtract a low pass filter from the original signal, you get a high pass filter, which is not terribly exciting, but if you subtract a high-pass filter from the original signal, you start to get some more interesting results. And if you subtract embossed signals, again, some cool stuff. Also, subtracting inverted versions or adding inverted versions, you can get through a lot of neat solarizations and other kinds of detail enhancing tricks and things of that nature. Could be very useful with key information too. Alright, and here finally is just one last example, showing an example of I guess what you call basic soft colorization. Not using any keyers, just using the filter, and it's actually just a slight variation of the patch that I was showing you before. So the video input comes in, I have 3 different CV sources that are basically just adding some variation to it, and then I'm just taking a low pass, a band pass, and a high pass output, and really I'm just taking one of each for fun. You could do the same technique with any of these various outputs. You could take all 9 of them in different combination, and I'm just running them into a blending matrix, and again combining them slightly with the originals just to add back some detail. But what it allows you to do is sort of isolate different ranges of the image and mix them back together in color, so you get a colorizing effect, but you get nice soft edges in between them. So it's not always the sort of hard-edged colorizing effects you're used to from the triple fader and key generator. And you can see our modulation sources starting to rock in there. Let's try some different things. And of course adding more interesting modulation sources, using some VCAs on things and whatnot is going to get you a lot further, but just as some basic demonstrations of the principles. And that's basically it. Thanks.